Today we are going to review for Quiz 2. Quiz 2 will be over sections 1.5 and 1.6 from your textbook. I have listed here 5 topics that are most important in these 2 sections, so be able to perform problems from each of these 5 sections. To start out with today, be able to classify whether a relation or an equation is a function or not. Now there's a couple ways of doing that. First way, you can look at a relation and ask yourself, does every domain have exactly one range? Okay, that's the first way. The second way is sometimes you can look at a graph. By looking at the graph, can you use the vertical line test to determine whether whether an equation is a function or not? Now, you put your pencil straight up and down along the graph, and if you only touch the function 1 as you lay it straight up and down along the graph, then it is a function. Okay, the second topic is to be able to find a function's characteristics. Tell us about the function. Does it open up? Does it open down? Where does it increase? Where does it decrease? Where is its domain? Where is its range? Where is it constant? Also, some other things that you might need to know are, where is its relative min or its relative max? Just some of the characteristics such as that. For example, again, where are its zeros? Okay, all these are characteristics that you need to know. Okay, the third thing, how does a function translate? Does it move right or left? And what part of the general form or the standard form of the equation causes it to move right, left, up, down, stretch or shrink, or reflect across the axes? Okay, so know those things. Okay, number 4, be able to show if a function is odd or even or neither. Now remember, function is odd if that function passes the symmetry for origin, and it's going to be even if the function passes the symmetry for y-axis symmetry. Alright, and lastly, be able to graph a piece function. Alright, now at this point I want you to pull out your review, and I want you to pause it. And what you're going to do is you're going to work question 1, and then you're going to play the video and watch how I do it, and then compare that with how you've done it. And then you'll pause it again and do the second question, and so on and so forth. Alright, so let's begin. Okay, here is our first question, and I have given you an equation, y equals the cubed root of x minus 10. And you're going to be answering the first 4 questions based on this equation. Now, the first question says, does the equation represent y as a function of x? So you need to determine. Now, what do you need to do? Well, let's pause it, and I'll give you a few moments to play with it, and then we're going to talk about the rest of this together. Okay, now that you've taken a look at this function, let's take a look at what you've done. Alright, first of all, in graphing this function, hopefully in graphing it, you were able to enter it into your calculator, something like this. So, you have y equals, and you hit the cubed root, and then make sure you put parentheses around whatever you plug underneath that. That keeps underneath that radical both the x and the minus 10. Okay, so now that you've done this, and when you graphed it, the first thing that you probably noticed is your window. If you graphed it just under the normal view, you looked at it and you didn't see anything, or maybe you just saw a dot right over here. You didn't see much of anything. And well, actually you probably saw a dot there, and then you saw this thing that kind of looked like this. Well, the problem with this is you weren't large enough on your domain. If you were to stretch that domain out where you ran from, say, I don't know, maybe -20 to +20, then you would see a window that would look something like this. And you would see your axes similar to this, and you would see that, okay, that is where the graph crossed the axes. Now, using your vertical line test. So you could put a line, across this, and you would realize that as you went across the domain, you only touched it once. So, what is your answer? Does it represent y as a function of x? Your answer is yes, it does. Okay, and explaining your answer, you could simply say it passes the vertical line test. Okay, and that is it for question number 1. All right, here's our question for number 2. What is the domain and range of the equation? Go ahead and pause it and work through it, and we'll talk about it in a few moments. Now that you've worked through it, hopefully you looked at the equation and saw, since it was f of x equals the cube root of x minus 10, hopefully you looked at this and saw it says cubed root. Because it says cube root, that means your domain is always going to be all reals. There's no way of getting an imaginary number in this situation because you can take this cube root of a negative number. So your domain here is going to be from negative infinity to positive infinity. All right, so what about the range? Well, take a look at your graph. If you look at your graph, just observe the graph. Can you see what the range is? Well, in this situation, the range, if you're a little person walking along the y-axis, you can look right or left and always see the graph. So that means your range is going to be from negative infinity to positive infinity as well. In question number 3, it asks you, is the equation even, odd, or neither? And then make sure you show your justification steps. Now, a little hint here. Don't just show the justification steps in saying the word odd, even, or yes, or no. You have to actually show me a justification steps and then explain your reasoning. All right, go ahead and pause it and work through this problem. Okay, in working through this problem, the thing that we need to do first is let's show if it is odd. So, in order to determine if the function is odd, we need to do the origin test. So that means I'm going to plug in a negative y for y, and I'm going to plug in a negative x for x, and we're going to simplify it. So that gives me negative y equals, we have the cube root, and I get a negative x minus 10. We're going to multiply both sides by negative 1, giving us y is equal to the cubed root of negative x minus 10. And then we're going to say, therefore, it changed, and it is not symmetric to origin, thus not an odd function. Okay, so there's one example of how you could write that argument. Okay, let's take a look at the next one. For an even function, this time you're going to plug negative x in for x. So I'm going to plug negative x here. Now make sure you show the step where you show the simplification of this. So that'll just give you negative x minus 10. And you say, therefore, it changed, and it is not symmetric to the y-axis, thus not an even function. Alright, so what does that mean? Well, since it's neither even nor is it odd, that means it is neither even nor odd. Okay? In this question, we ask you to graph and then be able to explain any transformation. Alright, so at this point, if you would pause it, go ahead and graph it, and then explain the transformations that occurred in the graph. Alright, let's look at it together. Hopefully the first thing that you did is you scaled this. So that's important. Now notice from up above we talked and we said you saw that the graph crossed at 10. So what I would do is I would probably go by 4s here. So 1, 2, 3, 4, 5. So that's going to be 20. 2, 3, 4, 5. Negative 20. 2, 3, 4, 5. Okay, now, so we're going to go here at a 10. So let me change pen colors here. And we're going to go here at about 10. So put a dot right there, and I'm going to label that. And then I see that the function goes something like that. Okay, now we need to describe what occurred to this function. Well, all that happened in this function is, you had the cube root, and it said x minus 10, so you're going to take a look in here, and you see it moved it 10 to the right. So you're going to say the function was translated 10 units to the right. Okay, and that's it for that part of it. In question number 5, you need to be able to graph a piece function. Alright, so at this point, suggestions to you is make yourself a t-chart, select some domain values in the function, and then from there plug them in, then plot them, and then you'll be able to see what your piece function will look like. Okay, so go ahead and pause the video at this moment and do this. Alright, so first of all, I'm going to take a look at the domains here. I see any value greater than 3, I'm going to plug into x squared. And any value less than or equal to 2, I'm going to plug into the x minus 2. Now I see that there is a hole that runs between 2 and 3. That means nothing exists in that point, that area there. Alright, so let's go ahead and get started here. So I'm going to plug in, let's plug in, say, a negative, we'll say a negative 4, negative 2, plug in a 0, and I'm going to plug in a 2. Okay, and then I see it jumps from 2 to 3, so I'm going to put a 3 right here, but I'm going to put, say, parentheses around it because I see right here that this is greater than, which means it's going to be open. Alright, now notice at the 2 right here, it is less than or equal to. So I suppose I could put a bracket around that, indicating that I was going to have a dot on that one. Okay, so it started at 3, and you could go 4 and 5, and probably don't need to go any higher than that because it's getting way large. Okay, so let's go ahead and create the range values from these domain values. So we're going to take negative 4, plug negative 4 minus 2, negative 6. Plug a negative 2 minus 2 is negative 4. We plug in a 0, 0 minus 2, negative 2. I'm going to plug in a 2, 2 minus 2 gives you 0. Now I'm going to plug in the 3. Now the 3 squared is 9, and remember that's going to be open. Take the 4 in there, 4 squared is 16, and 5 squared is 25. Now it's a matter of scaling it. So Along the domain, I am just going to scale it out to, say, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5 there. 1, 2, 3, 4. Positive 5 there. 1, 2, 3, 4, 5. You know what? I'm thinking here. I don't want to go to 5 just on the range here. I'm going to go, let's go by 5. So this here will actually be a 25. That may be too much, but we'll try it at that and see what we can do. So, looking over here, I'm at negative 4. So I'm going to go out here at negative 4, and I'm going to go down to negative 6. So it's going to be approximately right there. Okay? Then I'm at negative 2, and it's at negative 4. So it's approximately right there. And then I'm at 0, and I'm at negative 2, so it's approximately right there. Then I see that I'm at 2, and I'm at 0, so it's about right there. Okay, so this one here, I'm going to put a larger dot right there, and I'm going to extend that out because it is a line running just like that. Okay, now let's take a look at the other one here. The other one says when I was at a 3, it is at a 9. So now notice it is open. So I'm going to go up at 9 and put an open circle. Oops, not there. Got to leave room for the hole. So I'm going to go at 3 and I'm going to move at 9 and I'm going to put a hole right there. Now, this piece of it, notice it's x squared. That means it is a parabola. So then I'm going to go at 4, and I'm up at 16, so 5, 10, 15, so it's going to be about right there. And then when I'm out at 5, I'm up at 25, which is about right there. Okay, so now I need to kind of curve this because I know that it is a parabola. So I'm going to kind of emphasize that curve a little bit, and there it is. There's the graphing of our piece function. Okay, this wraps up the review for our quiz. I wish you the best of luck studying for this, and we will be taking this quiz next class period. Have a good day.